So in this lesson, what we're going to be looking at is how to solve these systems of equations that we looked at yesterday using algebraic methods. And there are two methods of solving a system of equations that you're taught about as separate methods. And I hope that what happens here is in the end, you say it's not about a particular method, although you might use one of these methods. It's about using your algebra skills to find the values of the variables. And sometimes it's going to be easier to do some things, and those things might be called substitution. Other times it might be easier to do other things, and we refer to those as elimination. It's kind of like when I talk to you about solving a radical equation. And when you're first taught about radical equations, you're taught step 1, isolate the radical. Step 2, square both sides. When you're taught how to solve rational equations, you're taught step 1, identify the lowest common denominator. Step 2, multiply everything by the lowest common denominator. The bottom line is you are using your skills. And part of your brain should be saying, I'd rather not have square roots, and you get rid of it. Part of your brain would be saying, I'd rather not have fractions, so you get rid of them. It's the same kind of thing here. We're going to get to the point, the goal is for you to get to a point where you're not even really thinking about what these methods are called, you're just doing math. So when we go back to grade 10, when you had systems of linear equations, we used two methods. And the words are kind of arbitrary. Elimination is used to take the two equations and add or subtract them in some way, usually by multiples, so that when you do that, the variables reduce down to one variable. You eliminate a variable. For example, if I gave you this linear equation, linear system of equations to solve, you can add those two equations together and get the simpler equation, 9x equals 26. Because positive y and negative y added together will give you 0. Incidentally, if these were the two equations, you were probably taught in earlier grades to subtract the equations, yes? I wouldn't. I don't like subtraction if I can add instead, because adding is easier. Adding is not fraught with as many mistakes that you can make when you subtract. So what I would do is I would multiply this top equation by negative 1 and add them. How many of you remember your grade 10 teacher showing you that? Okay. It's a way to avoid mistakes, or to at least minimize mistakes. So you add or subtract multiples of the equations in the original system. See, I don't know why. Substitution accomplishes the same thing. Your goal is to get rid of one of the variables. So how can we get rid of a variable? Well, I'm going to take the same system of equations. I think I had 3x minus y equals 6. And I had 6x plus y equals 20, right? And by the way, if I go back here to this, and you add these together, I go back to the original equation and you add them together, you get 9x equals 26. So now you know that x equals 26 over 9. And in order for you now to find y, you're going to take this number and substitute it in, No, I had it right to begin with. In here, right? So this is called elimination, but you're still substituting at some point. What you do here, and then you would solve that for y. We won't worry about what it is. What you would do with the same system if you wanted to solve it by substitution is you might say something like, well, according to this equation, y is equal to 3x minus 6. Just ponder that for a second. Yes? And what you do now is you take this and you put it here. So you would get a new equation of 6x plus 3x minus 6 equals 20. Guess what you get? 9x equals 26. It doesn't matter which method you use. Usually some method will be easier than the other. Easier is the wrong word maybe. It will be more straightforward. So do you remember doing this and calling it substitution? Vaguely, okay. So you rearrange one of the equations for a single variable and substitute the result into the other equation. You can use this for any system of equations, but it gets more complicated when you have a quadratic equation. So, example, solve the following system using elimination. You will notice, I hope you noticed, that when I write down a system of equations, I want to go back and just look at the system of equations before I started messing with it here. You'll notice that things are organized. Things are stacked so the x's are on top of the x's, the y's are on top of the y's, and numbers are on top of the numbers. And by the way, you could have written this system this way. All that is important is everything is aligned smartly, right? So I think that's the first order of business, particularly when you're solving something using elimination. The issue here is we have x squareds, we have x's, we have y's, and we have numbers in the first equation, but the second equation contains no x squareds. That's okay. When we rewrite this, we're just going to write x squared minus x minus y equals 6. And below it, we're going to write 2x minus y equals 2. And I know I said 6, but my brain and my hand wrote 0. So this is what I'm talking about with subtraction. If you can just put your pencils down for a second. The way this is traditionally taught is you would subtract the bottom equation from the top. So when we take x squared minus nothing, we're left with x squared. Then you have negative x minus 2x, which is negative x. See, even there, it's negative 3x, right? You have negative y minus negative. See, do you see me stuttering in my brain here? Because I'm subtracting and I'm going minus negatives and then minus positives. So let's just leave this up here, though, and then you go 6 minus 2 is 4. What if, and here's where you're going to write things. So I've got it here, and I'm saving it here. What if you don't do that, but you say, well, I don't like subtracting. I'm going to multiply this bottom equation by negative 1. This becomes a negative, this becomes a positive, this becomes a negative, and you are adding. What do you get? Well, you get an x squared minus 3x. See, to me, and I wasn't acting it up there. When I wrote negative x or whatever I wrote here originally, I had made a mistake. I'm being honest with you, I made a mistake. So to minimize those mistakes, we do this because it's easier to add those two things to get negative 3x. That's my advice. We don't need to write plus 0 here. We get equals 4. And now we see that what we have is a quadratic equation which we know how to solve. We zero the equation. And in this case, we can very easily factor this. I hope you're with me on that. Okay, that means that we have a solution of x equals 4, and we have a solution of x equals negative 1. These are not the two answers to the question. These are the two values of x in half of the answer to the question. To find out the other value, remember that our solutions will be an ordered pair. So how do we determine the y value? Well, one of our solutions has an x-coordinate of 4. One of our solutions has an x-coordinate of negative 1. To find the y-coordinate, put those x coordinates one at a time into any equation that has x and y in it. And I mean, I hope just generally speaking, I'm going to use this equation because I feel it's easier to work with. I hope you understand that you're going to choose the equation that you're more comfortable using. And if you're more comfortable using the quadratic one, go ahead. But to me, this is easier. So I put in, do it down here. Not sure why I have that twice. I can put in to y equals 2x minus 2. I can put in 4 for x and get y equals, help me out here, just make sure it's 6. Okay? So that means when x is 4, y is 6. And then I can go ahead and do the same thing here, put in -1 and get -4, I think. You better just double check me here. Okay. Those are the two solutions. I don't know if we were asked to verify them, but if we were, I'm not going to spend our class time. Yeah, we are. The thing about verifying these algebraically, if you put 4 in for x in this equation and 6 in for x in the same equation, you're going to get it true because that's the equation we use to find the 6 and the 4. I just want to point out, I'm going to save a bit of class time today. I want to point out that if I ask you to verify this on an exam, there are two methods that you can use. You can either put in the x and y coordinates into each of the two equations, meaning put four in for x and 6 in for y in the green equation, put 4 in for x and 6 in for y in the yellow equation, and make sure that they're both true. And then put -1 and 4 and make sure they're both true. Or I guess you could verify it by solving it graphically. But I want to make it clear, if you decide that on a written response you're going to say, I'm going to verify it by solving it using a different algebraic method, that's not a verification. You can't say, I'm going to use a substitution instead. Let's take a look at B. Well, before we do anything, let's get rid of those fractions. I've mentioned this a number of times. Why work with fractions if you don't need to? So this is pretty easy to do. I'm going to multiply this equation. I'm going to multiply this equation by 2. I'm going to leave this equation alone. And in preparation for what's about to come, and if this doesn't occur to you at this point in time, you'll just have to do it in the next line. In preparation for what's about to come, I'm leaving some space because I see that the second equation has x's. So I'm going to have x's and y's. When I multiply this x by 2, I get 2x. When I multiply -3y over 2 by 2, I'm left with -3y. And when I multiply -11/2 by 2, I'm left with -11. So I want to eliminate these. And very often with algebraic work, when you're solving things, systems of equations algebraically, you end up kind of going all over the place. So what I did here, and I wasn't really thinking about it, is I wrote those two equations to the right. Well, now I'm going to do something with them, and I'm going to go back down to the left. I suppose you could just work down, 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 but you don't always have the luxury of that space. I cannot add these equations just yet to get rid of a variable. But with a little bit of thought, if I multiply this equation by 3 and by a negative, that y will become positive 3y. You're going to have to learn as you move forward, particularly if you get into 30-1 and then calculus, you're going to have to learn to be very organized in your work. And there's nothing wrong with me writing that over here. There's also nothing wrong with me saying that. I mean, I have made an effort here, and I'll even exaggerate it, to really separate these two equations now from what's up top. So it's not just this run-on sentence kind of thing, run-on mathematical kind of sentence where you're just looking at this and this and this. You can see what's happening here. And I don't know, math sometimes is about communications. There's nothing wrong with communicating what you've written by doing that. I moved left to right here to demonstrate to you that I'm multiplying this by 2. You know, if I had enough room, I would have still moved left to right and multiplied the top equation by -3. I'd be very careful because I know there are people in the room that are smart enough and good enough at math that you could do both of those things at the same time. But it's risky. It's risky. Okay? So what do I do now? I add these equations. And, you know, in hindsight, this is going to work out good because then I'm going to have some other work to do that's separate, and I can do that over here. So when I add these equations, I get -3x squared plus 2x equals -14. I think we want to zero the equation because it's quadratic. I don't think. We know we want to zero the equation because it's quadratic. I'm just going to pause there because I see a couple of furrowed brows. I see a couple of people looking at it questionably. Are we okay with that work? Yeah?
Shouldn't that be equal to +3?
Should this be +3? No, because we multiplied the original 1. Oh, and it was an original -1. Thank you. Yes, this is negative, which makes this positive, which makes this -8. Thank you, Sukman. There's that thing I've talked about before where, and I don't often do it, so I make mistakes, and you'll make mistakes too, checking to make sure you've copied things right from step to step. So that's -1. When we multiply by -3, we get that. Is that better? Okay. So we're going to zero this equation. We're going to have 3x squared minus 2x minus 8. And then we want to look at the potential of factoring that. Is that factorable? I believe it's going to be because I believe you get 100 for the discriminant. I'm seeing a couple people nod. You know, it would be kind of rare, although not unheard of, to solve a system of equations where you end up with irrational solutions. Okay, we may encounter that. We may even encounter it today. It's probably 2 and 4. Thinking 4 here and 2 there. Gives me a 4x for the inner, and my outer product is -6x. There we go. Don't forget the equal 0 here. It means 3x plus 4 is equal to 0. And we also have x minus 2 is equal to 0. So x equals -4/3, and x equals 2. Now we have to find y. I'll be honest with you. Elimination, I like elimination better initially to find the first variable. But I like substitution better to find the second variable. It's kind of a toss-up here. So one of our solutions will be -4/3, comma something. One of our solutions will be 2, comma something. And I forgot to mention, I made a mental note to mention it, and it's important. There's nothing particularly special about solving systems of equations. That's not why we're teaching this to you. We're teaching this to you so you get better at algebra. That's really the bottom line. Will you ever use this? Yeah, but that's not why we're learning it. I would probably go back to the very beginning and use this. I would probably go back to the beginning and use that. It's the simplest. You know, even if you get rid of the fractions here with the second equation, then you're dealing with something that has 3y in it. The first equation can be rearranged for y very easily. So it's x squared plus 1 and although I have harped on you all semester long about know how to work with fractions on paper, look, when it comes to this point in the course, take your calculator, take negative 4 over 3 in brackets, square it, and then add 1. And you'll get 25/9, I think. Is that right? So the y coordinate of this solution is 25/9. And then put 2 in here and you're going to get 5. And those are the solutions to that system. We're good? Okay. Solve the following system of equations using substitution. Just, I think it's valuable to know this. Why do you think you would want to use substitution here? Let me rephrase that. I'm not asking why you don't want to use elimination. I'm saying, why is substitution a nice first step? Don't forget, for substitution, you need to rearrange one of the equations for a variable. The answer is because there's a negative y in there. It's very easy to rearrange that equation for y. Whereas lining everything up and elimination, I mean, look what, let me do this. Let me show you something. Don't write this down. Negative 4x squared minus y minus 2x equals negative 5. 3x squared minus 4y minus 46x minus 37. So that's equal 30 to 37. You saw what I did there? If you want to eliminate the variables, I hope nobody in their right mind is going to multiply the top equation by negative 23 to eliminate the x's. You could multiply the top equation by 3 and the bottom equation by 4 and eliminate the x squareds, but then you're still going to have x's. My point is you have to eliminate the y's. You can't eliminate the x's because you can't eliminate them both at once. But that means you're going to multiply the top equation by positive 4, and these numbers are all going to get bigger. Okay? Now, it may turn out that we have to work with bigger numbers anyway, but I think it's a wiser move to just say, in this equation, y equals negative 4x squared minus 2x minus 5. Nope, plus 5. So I've rearranged that top equation for y by moving the y that's negative to the other side and popping that 5 that's negative to the left side where it's positive. And what's going to happen is this is going to go here in the second equation. Are you with me? This is what I mean by getting better at algebra. That's why we're doing this. So what do we get? We get 3x squared minus 4 times this beast minus the 46x minus the 37 equals to 0. So we have our 3x squared, then we have minus 4 times y, but this thing that I'm highlighting is y, then minus 46x, and then minus 37. So what now? Well, simplify it. Right, you have to multiply that negative 4 through and get 16x squared, 8x, and negative 20. So there you go. We're dealing with big numbers anyway. Minus the 46x, minus the 37, equals 0. So now what we have to do, I'll double check my arithmetic there. It looks okay. Now what we have to do is simplify this, and we get This worries me a little bit, 19x squared. So it's a peculiar number. I was going to say odd, but 19 is odd. That's not my point. It's a peculiar coefficient to have for a quadratic. What do we have then? Negative 38. Ooh, I'm getting happier because 38 contains a factor of 19. We can only cross our fingers that the remaining constant term will contain a factor of 19, and it does. It's negative 57 equals 0, which brings me to a point, and I didn't check, and I will feel bad if we could have done it. Can either of these equations be simplified to begin with? The answer is no. Meaning, can I divide everything in the top equation by 2 or 3 or 4? No. Can I divide everything in the bottom equation by something? No. You should always look at that. So I can take a 19 out. When you see something like this, don't dive right into factoring it as binomials. Ask yourself if you can take that 19 out. And I think you can. I'm pretty sure. This is 2, and this is 3. Negative. Negative 2, negative 3. That means that x is equal to 3 or x is equal to negative 1. And this, everybody, is why I like substitution. No matter what, you have to now use that x, each of those x's, to find a y, but you already have made an equation for y. Right? This is y. It's already done. So you need to put, I think I said negative 3? Positive 3? Everybody, you need to put positive 3 in here and work out what we're going to get. And I'm going to say negative 37. Okay. Don't try to read any mysticism into the fact that negative 37 was part of one of the equations. That's just a matter of circumstance. That's a fluke, coincidence. And then we need to put negative 1 into this equation. And I'll give you a second to confirm or deny it, and get positive 3. Okay, so those are the two solutions. We have one more to do. I would say that we could probably just finish it here, but let's do one more. As soon as I see, it's just me, as soon as I see one of the two equations, and it's a fairly simple equation, and it contains a negative y or a negative x or an x, I would use substitution. I don't know about the other equations. If we go back and look at this one, substitution would have been easy for me. Here, I don't really like the idea of substitution unless we get here first. Then I would use the top equation. But if this was a 7, you're not going to use substitution. You'd use elimination for sure. Right? But let's take a look at the last one. We are asked to use substitution here. The first equation can be written as y equals 5x minus 10. And that means, since this is y, we can put it right here. Right? Just to show you 5x minus y equals 10, I add y to both sides and get 5x equals y plus 10. So I subtract 10. That means that the equation I'm going to solve is this. x squared plus x minus 2 times y, but y is 5x minus 10. You know, the rest of this is just, it's just tedious work at this point, isn't it? And I mean that sincerely. The hard work is done. The heavy lifting is done. Now you just have to solve a quadratic equation, get your two answers, and find y. This leads us to x squared minus 9x plus 20 equals 0. As I said, I don't think you're going to encounter, well, probably not in this unit, in this course. In calculus, yeah. And notice sometimes I say in calculus and I just bypass math 30-1. You would never, the only time you would get a quadratic equation, I got to be careful here. You might encounter a quadratic equation in math 30 that's trigonometric or logarithmic or one of those math 30 ideas, but it would not be a system. Not where you have to take that x coordinate, which will be an irrational number, and put it in somewhere to find y. Okay. What are our two solutions? Our two solutions are x equals 4 and x equals 5. Well, what are the two halves of the two solutions? That. We still need to calculate the y coordinates. But again, I like this because I've already calculated y is, I'm going by memory here, so can you confirm it's 5x minus 10? It's just a matter of putting 4 in here and calculating the y coordinate. The y coordinate ends up being 10, I think. Now what you're going to do is you're going to put 5 in there and calculate the y coordinate. And you're going to get 15. So those are our two solutions, 4, 10 and 5, 15. Today is an algebraic mathematical workout. That's what this is all about. So you have some textbook questions. You have some additional problems you can practice. I'm not going to tell you how many you should do or what you should do. What you need to do is get better at this. Be better at it when the bell rings at the end of the class than you are right now, and be better after tomorrow than you are right now.